When we got together as a group, we were talking about the streaming data, and we're talking about all the content, talking to this extended vehicle. And really the foundation of that said, well, wait a second, this is all really what the title's saying. It's foundational elements and collaboration enabling new vehicle user experiences. So with that, the abstract actually totally evolved, and here's the abstract. But what we're going to be talking about today is there's elements, and the whole foundation of this panel is the weave to believe. We have a variety of players that are here today, and I'll give some reason and rationale why they're here. Well, you're stuck with me, gatekeeper, bad guy, good guy, whatever, but moderator of today's panel, Mike Blicher with Innovation Works. But I have today Brian Carlson. And at the end of the day, it was kind of neat what Partha said, oh, the new commodity is sand. Well, sand evolved is what it's all about. Here's our silicon foundation. This is really the heartbeat of what creates the ability for the disruption to occur. If you can't do it on the silicon, you can't make the things communicate, can't make the things happen. We're all just, smoking in Michigan, right? Then what I have is, I have Bernd. You say, well, what's Tuxera doing here? Well, here's areas that may be something lower in the stack, but even what was brought up by General Motors yesterday, what's elements that are not part of a specific brand? All these read-writes we have to do on data become crucial, and we were having a discussion about the software-defined vehicle. When does it not become the STD, right? Could it be a disease that kills the vehicle? What happens with those read-writes? What happens with the TCP/IP that you have to optimize that, yes, we're an extension of as an IT element, but how do you do it in a vehicle the right way and it's not a new gateway for cyber attack? So that's what Bernd to bring his insight. Then Dave's background related to user experience. He's a total believer the experience is from the time it wakes up in the morning until you go to bed. How do you interact with this vehicle? What is this mobility? Not just an infotainment element on a display, but the whole experience with the vehicle. And then we have with us Tim Yerdon. Tim has been both at OEMs and at major tiers, has been one of the disruptors on looking at this evolution on where the technologies are going. So we're going to have like what I call our 4 C's of discussion with the cooperation, courtesy, coordination, and clash. Have some of the clash on what we need to do in this area. And once again, this is setting the stage for one of our announcements of a new user group that's coming up this afternoon that Stellantis is going to be helping support lead. So this is kind of a preview, so stay tuned. But I'm going to toss out and let Brian take the talking stick. So once again, from the silicon perspective, you've been in this game for a long time. Partha said this is the most disruptive time of the world. John Ellis would say, well, we were 12 years late. What do you think about what's going on with this whole area?
Yeah, definitely. And I've lived this life before because I was in the mobile market before we had smartphones and helped drive that whole thing. So this is kind of a redo of the whole smartphone, and we went from our candy bar phones to smartphones. If you think about a lot of things about moving data, having security, having high bandwidth connectivity, it's very, very similar. And a lot of the people I worked with in wireless are now in automotive. So yeah, definitely I would say what's really setting the foundation for the future, the architecture of a 21st century vehicle to really do this digital transformation to digitize the automobile are these new architectures, which the foundation is silicon. Previously, we've heard in other discussions the models where an OEM would spec a box basically to a tier 1. The tier 1 would get bids from different silicon providers, and they'd provide the box back up the chain. That's blown up now. That the OEMs have to look holistically, and I think that's a key word on everything we're doing here. We have to think holistically, not just as hardware people, not just as a domain expert, not just as an OEM. We have to all work together and look at all these angles. And that's what the OEM is doing. They're looking across the vehicle. And the supply chain really amplified and I think accelerated these efforts because they found one chip could shut down a whole production line, or they have a bunch of cars in a lot that don't have motors for the seats or something. So they're going, instead of having a dozen vendors and maybe 50 different types of processors, they're going to consolidate. And that's the first thing. Supply chain, making it simpler. The technology also has to support this whole new data architecture to be able to get access to all the data across the vehicle. Not captive data, that just goes to one box and just sits there. Right now, there's so much data that's in the vehicle that could be used to create new experiences, new synthetic sensors or virtual sensors. You need new technology, and that's from the silicon perspective, that's the foundation of going forward. It's not about a bunch of 100, 200 micros all over the thing that are distributed, that have different security, that have different types of infrastructure. It's about going to more consolidated processors that have common security, which is upgradable to post-quantum crypto, which can work together and be updatable throughout the vehicle. Not just infotainment, not just one or two boxes, but the whole vehicle will be updated. The whole vehicle will provide access of data to the cloud and to mobile phones. So silicon starts there. It's about consolidation and new types of silicon to be able to enable this future. And that's where we play. And we can talk more about that, but maybe that's a starting point.
That's a great one. Tim, go for it.
Yes, I'm just, as I've been here for now 2 days, 2.5 days, I've done a lot of reflection, and, you can see some of the lack of hair, which lots of battles up there. But, I just, we're flashing back about 15 years ago where this thing called software-defined radio was talked about. And I start to think about that from years ago, and it was really a microcosm of an exponential problem that we have now on SDV. And it all comes back to, I remember when I was at the supplier side, working with a silicon vendor, which happened to be this company over here, and working with a lead partner or an OEM to say, hey, let's do this. Let's take that leap of faith. But it all came down to requirements capture. And not requirements capture for what are we doing on start of production day one, but what do we want that silicon, what do we want in that chip for the life cycle of it, so they can make sure it's in there for a business. And doing that requirement capture, and not only for us, but go out and talk to our competitors, other OEMs, do that, bring it back, let's build this, and then let's implement. And obviously it's gone exponential with what we're doing now in the industry, but those basic principles haven't changed, and it really comes back to the requirements capture and the collaboration. And many have, if you've heard me on other panels and other forums, there's those that talk about collaboration, and there's those that do collaboration. We have to be the ones that do it. I've seen many people up on this stage and talk about collaborate, and then you try to get a business card, you try to get a meeting, and they ghost you, which seems to be the thing lately. But that can't be the way. We can't take on this complex of a problem if we're not collaborating.
Well, in my young days when I wasn't gray, and Johnny Cash brought out the Ring of Fire, and we had the CAN bus going around with all of these boxes talking. Well, now the Ring of Fire is now a nuclear reactor in meltdown with the Ethernet. So, Bernd, I'm going to put you on the spot. Talk about now that this IT mindset, when your background was, once again, the IT world, how to make servers work and work and work better. But if you had a problem, all we had to do was, boom, add another rack, and life went on. Well, I can't get the car back to add a rack. So what's happening with this whole Ethernet world that you're trying to face in this new area of getting these streams working?
Yeah, that's really a good one, and it's not just the Ethernet, it's really going further with the foundation that we're just talking about with the silicon. There's so much things changing and going on that neither tier ones nor OEMs have been used to, so they experience something new. And then with all the relationships and the responsibilities changing now, it's even getting more complex. What I mean with that is, in the past, with all those single ECUs, Partha was talking about the kitchen sink approach earlier, those were really self-contained, very much specialized. So you were flashing those once, it was specialized for one function. There wasn't even any update over lifetime. So literally it was a read-only system. And that now changes dramatically with all these zonal controllers, high-performance computers, more computing power than anybody has in its laptop is in the car. And now there's a lot of more writing going on, data being streamed, being transported. And that is actually now putting some stress on the memory, on the storage, on the flash memory. That's where we are coming from, being experts there as well. And that is something where, well, you might remember 4 years ago, actually, in November, where Tesla had the headline, oh, they had to replace the head units because they were writing too many times into the flash memory. And that is now 4 years ago, and now the other industry is just entering into the complexity of those systems, and you can't simulate that. You only simulate what you're expecting. Nobody expects something is going wrong with the storage, because everybody wants to separate the hardware from the software development and forget about the hardware. It's not important, right? Why bother? But yeah, it is. Because if you build on that foundation and you have a weak foundation, then it's like building a house. If you want to put in a fancy apartment and, oh, a swimming pool up there in that apartment, and another swimming pool there, another swimming pool there, and you're not caring about the foundation, then it will collapse. And it will not collapse before you go SOP, where you have a chance to do something. It will collapse 4 years after, maybe.
And that's
Yeah,
maybe-
so Dave, I was going to come to you and say, your whole background of at times putting together hardware and software solutions to do these initial POCs, how do you see this explosion impacting you related to the challenge? So go, please continue.
So I think one of the really fundamental problems is kind of reversing the paradigm of where we start designing, right? And John Ellis talked a little bit about it yesterday in terms of the nature of where we focus attention in terms of the requirements of the product. Traditionally, that's been a very hardware-centric type of discussion. And I think the future in terms of what we're enabling from a software and a software architecture standpoint has to put software first. So just like you were talking about sort of those fundamental foundational questions, you've got to take the problem back to that level to be able to start to put in place the planning, the infrastructure, and the capability to support that end software user set that people want, that end set of features that people want. And I think that's the other piece when you dial back into the customer-driven piece of things. This is not, again, just the end vehicle as the product. It's the software feature and functionality that people are demanding. The manifestation of the hardware happens to be a car in this instance, but it could very easily be something else, whether that's a mobile device or others. And I think that's the design paradigm shift that's occurring. The other thing that I think is also happening from a traditional Tier 1 relationship, I've been part of a number of Tier 1s over my career, just recently with Morelli. And changing the paradigm in terms of where design occurs from this context of co-creating for this future feature set is also another important part about it. Because I think that sets the requirement stage up front for how you're going to build, how you're going to deploy, and how you're going to really make something going forward. So that's the other piece that I think has to happen in this new world of design and development and execution.
Well, I see that, the OEMs, they keep talking about what was once, so all in-house when I first got out of college, that got all distributed, and now they're talking about getting more back in-house. One of the challenges I still see is that the silicon is maturing at such a fast rate, and I'm looking for everyone to try to comment on this, and this is not just a commercial for NXP, but one of the things that impressed me about NXP, they take the field application engineer approach to a university level, like this upcoming event at St. John's again that they have basically yearly. I've never seen a greater cross-collaboration of OEMs, tiers, subject matter academia going to these workshops where you're not just getting an EVK or a dev kit that's back-ordered, you're getting stuff that's available today with the documentation to understand that architecture. Do you see every silicon manufacturer has to step up and replicate that kind of real-time university mindsets versus, pay to play, I'm close to you, I can get this kit, I can't get this kit. How do you see the industry changing? I'd like everyone to comment on how does the OEM deal with the in-house when they don't have the capability to do it all, so they still have these other partnerships. Silicon can't feed everybody everything in real time. How do you deal with it? I'm using the model of what NXP does with the university educational program yearly. How do we step that up to a bigger thing for the industry to grow? So, start.
I mean, I'll just maybe take it from the other end from an OEM perspective, and some of the challenges I had at my last employer from an OEM was, even pre-dev kit. We are trying to demonstrate and show the what ifs and the future possibilities to chief engineers, vehicle line directors, vice presidents. We want to have this type of experience with these displays, and the next thing, I can do it on a laptop. But then the next question is this real? Can we meet production? Can we actually do these things? So even if it's a bunch of cobbled hardware together, we want to have that type of collaboration early on to give the executive teams the confidence that we can actually deliver these things through the gates, through the milestones, and be able to deliver the experience that these customers want. And you know, it's a tough thing because you're not ready, we're not ready, nobody's ready, but we have to demonstrate, we have to show there's a path to production. And oh, by the way, there is no SOP. The SOP, those things are going to fade away. I think somebody mentioned that yesterday or the day before. You know, it's really now on day one when you're creating these products, what is your OTA plan? What's your plus 60, plus 90, 180, 2 years out? You need to be thinking about that. What are those features and functions you want to have at a year out or 18 months out or 24 months post-production? Because those all have to be incorporated all the way down to silicon level.
Yeah, and I'd say from a silicon provider perspective, the world has drastically changed. I've been in automotive for 6 years prior in the other market with mobile. But when I first joined, it was about here's a chip, maybe the eval board, and here's a MCAL, and now with Linux, here's a BSP. But the world has changed, and maybe you've seen some of the platforms that were out on the floor during the showcase. You see our gold box and such. We have put together complete solutions all the way up with complete stacks with all the Linux, AutoSAR Adaptive, AutoSAR Classic, integration with AWS, actually doing the integration with partners. So it's very important to have those platforms so then the industry, not just the automotive ecosystem, but people outside the traditional automotive ecosystem can come in very quickly and start to innovate, which is what we need. We need to bring new blood in, new talent. They can say, oh, I know how to work in a Linux environment. I know how to use Kubernetes. I can go on that platform and do it today. So I would say having those types of platform solutions are critical. Now, there's different levels. How do we build the pipeline, right? The academic is very important, right? We do a lot of internships. Hundreds of people a year come in, students from around the world come in. We do that. We do a lot of university training. Having those platforms, having the ability for them to work on real projects is critical. For the OEMs, like you're talking about, even 2 years ago, I was working with one of the major OEMs in Detroit area. They're working on 2030 mobility use cases, and having the platform with time-sensitive networking capabilities and all that available, having those platforms ready with software, ready to move quickly is critical for the OEMs to move quickly with the technology. So bottom line, what I'm saying is it's not just here's a chip and here's a driver. It's like here's a whole platform, here's a box, reference designs that OEMs and tier ones take to actually automotive grade reference designs that they can take. We're not trying to be a tier one, but we have to be able to do that because of the level of complexity of the devices. We have to make it simple and fast to market. Customers in China, you give samples to customers in China, 18 months later, they'll have a vehicle on the road. It's crazy, but enabling them to do that. Yeah.
And I think you can see a lot of that that's happened, you know, with what's gone on from driver assistance solutions all the way through to platforms for autonomy, being on the idea of what it takes as an entry point for software development. And a lot of institutions, you know, focused, you know, initially sort of on computer vision, and then computer vision transitioned to sort of general purpose compute on GPU. A company like NVIDIA builds, you know, a tool like CUDA to enable general purpose development targeting those GPUs. And then fast forward to kind of where we're at today, and you've got a whole family of sort of machine learning SoCs that have now developed with higher level of entry points of software where, you know, you can open it up to a broader development community. And that's the way that, you know, the educational community is kind of expanding and supporting, you know, these modern platforms, which is really exciting.
Yeah, tooling is really important, especially in machine learning, and definitely to be able to have someone that's not a data scientist necessarily, to be able to take those models and to bring them into the environment and to run them in an automotive grade A-SPICE machine inferencing engine and have that available at their fingertips is really critical for them to move quickly. Yeah.
The only thing that I think we need to be really careful with as that goes forward, though, is it's great to add that level of abstraction for ease of use. The challenge that I think we have is then making it efficient as it goes forward, right? So you can very easily kind of create these modern platforms for development, and you can create a whole level of engineering community to support it. But my one concern is, like, as that goes forward, do you still have the depth of knowledge that goes down to execute efficient, you know, functionality on the actual metal itself? And we see a whole host of processors out there right now, you know, that are really being not fully utilized in terms of, you know, the actual code targeting the functional hardware that's beneath it.
That's an interesting dynamic, and I've been in electronics for 40 years. This is my 40th year, actually. August is my anniversary, and I still remember the early days when we're coding. The best coders were double E's. I'm a double E. I have a master's in electrical engineering. not the software people, the best coders at the time, because they understood the ins and outs and how to actually get the most out of the hardware. But as we've seen over the last, just few decades, that's changed dramatically, right? It's about software, it's about abstraction. The people that are writing software don't know what's under the covers, but that almost because the technology has gone so far. When I was working at 2-micron technology, now we're doing 2 nanometer, and it's amazing what you can do, but you cannot. We can give you a 10,000-page reference manual, or we can give you the APIs that do it for you. So I think we're at that level of the complexity of these devices where it does abstract, but it leads to that issue that you could if you wanted to, but people don't have the time. Because of the time to market, they don't have the expertise like a Double E would to really understand the ins and outs of the chip sometime. And so you do have to abstract it to make it easy for them. They can go to market quickly. And that is an interesting dynamic. And it probably does leave performance and capabilities on the table because there's no time to fully do that. Now, what's interesting, OEMs will come back, and we actually support customizations to do that in certain cases where they want to do that. But I would say in general, you hit a key point that's kind of the trend you see is don't optimize. The problem is that drives cost because now I need more memory, which is good for some vendors. They want to sell memory too, right? But they need more performance. The power goes up. So it has a very negative effect, but it's that trade-off. You have to find the right balance. So.
And that's the part where I would then go back to what we were just discussing at the beginning of the conversation here, which is flip the requirement set around, right? So start the problem set at the definition of the functionality of the software, and then let the architecture of that software start to inform what you think that you're going to need from a supporting hardware infrastructure beneath it. And again, I would agree, we've gotten through levels of abstraction where that gets a little gray, but I almost think that we kind of need to have a little bit of a reset and pull it back together so that, again, you could start to do that headroom planning, longer term, right?
Yeah. It's co-development, and it used to be where you have our FAEs or sales, and people go in and talk to the guys that are just microprocessor guys or MCU guys. Now it's software architects, it's security architects, it's functional safety. I mean, I've been in meetings where we had 60 people from an OEM in one room just to go through it because they all need to be a part of it. It's a co-development. It's not like the old days.
Yeah. I'm laughing because I vividly remember the meetings of justifying why we wanted 50% headroom in an infotainment platform. And before the development was done, because this particular OEM never bought extra headroom, by the time the development was done and all the feature creep with the different chief engineers and various platforms, boom, it's full. Then the same executive that was yelling at me why we wanted to have the extra headroom is, why didn't we buy more? So it's, you really, once again, thinking way out into the future.
SDV amplifies that even more, and that's the point I tried to make in the previous panel. You cannot think like that, and you have to have those, I wouldn't say battles, but you have to have those discussions and education with the procurement people. I've done that. I think they're coming around. They understand it now, but it is an issue. You have to plan for the future, as we're saying. These things have to live 15 years plus, right? And like you're saying, it's an agile process, and new things get added continually, and they're investing in that to make revenue from it. It's not just a chip that's going to go in like you were talking about. It's just a chip that's a black box. It sits there. It never gets updated. The world is different. That chip is going to improve and get better with new functionality. That's going to generate revenue. If you look at Stellantis and others, they're all quoting $20 to $30 billion a year of incremental revenue, I think, right? It's $250, $300 billion a year in the industry. That is real money that's out there, and they need to invest in it. If they don't have the proper platforms that can scale and have that overhead, that $20 billion starts to drop.
And that's actually a very interesting development going on, that there is so much discussion and collaboration going on from the processor side. And I think people learned a lot already in that space and are still learning. But then again, the community has to do some other learnings to have such discussions, such planning, such workshops, benchmarking in other areas around the storage as well, because that is the next thing. Okay, you have your silicon now with regard to the processor, but now what to do with all the data, how to store it in a safe way that you do not get data corruption. For example, well, what is the typical power down cycle for a car? Well, you pull the plug as a comparison to the real world or to the other world. Now, with that, data corruption takes place if you are not taking care of it. And we've seen that with some of the discussions, and I actually discussing that with another client, Again, Tesla, where there are investigations going on with this unintended acceleration, and where some of the investigators have thought that in the traction inverter there might have been a spike leading to that. And yes, exactly with another client, we are discussing that, well, okay, we have the data, all the configuration data, and if there's something going wrong with the file system handling that due to a power fail, then it could be that after power up again, the car accelerates. And that would be a critical situation, of course, very safety critical situation. And thinking about what's going on with that storage, what impact it has, actually it has a really very, very bad impact in some way. It's getting slower over time. In 4 years, you might get 20% drop in performance of your system because, welcome back fragmentation. It still exists with flash memory, and it then suddenly really has an impact on not only on the performance, but then also on latency, where if you have video going on, then you have some frames dropping, missing, and so on in the video, not that good either. And a lot of those effects that people are not thinking about at this point of time. And worst case, experiencing that in 5 years from now. And that's then if somebody like GM had to recall suddenly 2 million cars to exchange the head unit, ouch, I think that should be avoided. And that is where we are now trying to really get the awareness, and some of the OEMs have actually taken action on that. We are doing flash testing even with them to see, okay, how do those elements that you can buy from the different vendors, how are they working in the workload that you are predicting in your next application? Will they survive those 15 years, or will they die earlier? What about the data retention if you park the car in Arizona? Yes, it could happen that if you park the car in Arizona for 4 weeks, that the flash cannot be read any longer. Funny things, it's an interesting component, and it's not even a component, the flash memory, because it's a very, very embedded system as well, with a lot of software on it. You can have 10 to 17 chiplets on an SSD. So that's a very complex system on its own, and I think people need to still understand that and learn about that. And that's what we are trying to really educate people on and work with them to avoid any risk.
Go ahead.
Just a quick thing on the memory. I'm glad you brought the memory up because a lot of people don't talk about the memory, but definitely those issues are key. And we even looked at the impact of memory for 2 key things. As you go to these zonal architectures, when you approach the vehicle, you need to be up and running immediately, and there's a fast boot type of time. There's also over-the-air updates. Over-the-air updates are getting larger and larger, and flash technology is fairly slow relative to that. So what we've been doing is looking at that from the silicon point of view of how we can do fast power-up. So our chips are designed now to do even faster power-up. But also we announced with TSMC we're using MRAM. So we're replacing flash technology with MRAM. We can now do what took 60 seconds to do an over-the-air update, we can do in 3 seconds. So it's 20 times faster. I think it's 10x the endurance. So just to let you know, we've been investing in technologies, not just the chips, but the memory also, because I'm glad you brought it, because you have to look at the system. You can't just look at the chip. And we didn't talk about the networking and how you move the data, but that's a whole nother area. You have to look at all of the system. It's a system solution, not just a chip solution, not just a software solution. Like you said, all of us have to be working together.
And this MRAM thing, that's really a good thing if you talk about the processors, because there it is really efficient. But if you talk about 128 gigabyte, yes, then that's still a problem. And the question really is, the technology will improve because it's around for 20 years already, and it will certainly improve over time. But then the flash technology will improve as well again. So the question really is, will the gap be closed? Will it be interesting with regard to commercial aspects? Okay, we will see. But until then, we need to live what's available with, and that people are willing to pay money for. That's the other thing.
Well, I'm going to open up to some questions, but I'm going to toss out one thing, and hopefully the questions go in this direction. The area of this restructuring of the OEMs and this whole everyone getting a seat at the table. You can be a young startup, and if you're a hot startup, you can get right to the front row and have a good discussion. But the system validation of the software element, the hardware element, where is that ultimate ownership of all of the nuances that could be the things that bite you and kill this software-defined vehicle architecture? is there a thought that you have that I'd like to open up to the group to ask questions more on that? Is the OEM doing enough in restructuring? I know by titles they're not, because everyone has the same title. Head of architecture, head of software architecture, head of vehicle architecture. I mean, I'll read like 8 people with the same title. Who's the owner at the end of the day? Or is everyone, hopefully they get their 7 quarters of bonuses and they're out? I don't know. Are we really doing the right thing related to the whole system testing and validation? And how does this software, hardware, digital twin come into play when it's still in fragmented areas versus a holistic, really working model that we know it's working right? So throw a BHAG out there.
There's a lot to unpack out of that one. So I think some of the challenges, and I've heard it, articulated over the course of the last couple of days. One is transparency in the system, and certainly a lot of the technical teams have kind of talked about that. And what I mean by that is, in a lot of the architectures that you see today, ownership of how my function gets implemented all the way across the modules that actually delivered in vehicle is done by so many different people, and you may, as an OEM, have access to that code as source or not, and oftentimes it's the latter, you don't. And therefore, it functionally is a black box. And I think that's part of the challenge when you look at the system validation question end to end, because you can't do that. So there's an advocacy piece that I think needs to be made, or at least a decision point that needs to be made within the OEMs to say, I'm going to control my destiny in that direction, and I'm going to differentiate by owning that end to end and enabling that to occur. So I think that's one sort of fundamental architecture question that has to kind of shift. Some OEMs I think are headed in that direction. Some are not. Some are hopelessly kind of still, again, like we talked about before, they haven't changed the construct of the problem, and so therefore they're getting the same result. And again, we keep articulating that sort of over and over again. I think there's a little frustration that kind of comes with that too, because until it changes, you're going to end up with the same result over and over again, and I think that's something else for us to watch.
Yeah, and I'll give maybe an example from history that I was involved with Daimler. When I was at Visteon, we were peddling what they called domain controllers 15 or 10 years ago. This would have been 2014, 15 timeframe. And domain controllers, what the heck's a domain controller? We had to work with a lot of the analysts to start to talk about how these things were going to get consolidated. But that aside, as we were pushing and quoting and out to every OEM in the world, the traction with Daimler took place. And eventually, as the sourcing became closer and closer, and these are big programs 10 years ago, $500 million to $800 million in revenue over the life cycle of these programs, which are huge back then. But we had to go meet with the Daimler board. Daimler came to that conclusion that I don't need all these engineering people, or I still need the engineering people, but we need one person that's going to own it. I don't need all the buyers and purchasing. I need a buyer that's going to own it. So they understood and figured it out very early that they needed to restructure their organization, not just engineering, but other organizations, to be able to deliver these types of platforms. So I think they made the early change and got it right, but that was really just for cockpit domain controllers, infotainment-related connectivity cluster. That was just a small piece. That's one of the zonal pieces today. So I think others are struggling. Others that weren't willing to make those leaps, that were just so embedded in their history of their organizations. I mean, these are collections of many chimneys that are hard to work across. To try to work horizontally across these never-ending chimneys, it's very difficult to get anything done in some of these very mature OEMs. So no offense to many of you from the OEM, but it's just the way it is.
But even as you mentioned, Daimler, it's kind of interesting. They were picking up those kind of topics very early, yes. But still, and even more now with the changes, they are facing still challenges in a way that those electrical engineers who are the bridge between the mechanical engineers and everything else, those electrical engineers always were aliens within the organization because, well, mostly it was mechanical engineers and the electrical engineers were there. What's those guys? Now there are more software guys even. And for one electrical engineers, there's, 100, 200 software engineers. And those electrical engineers, now suddenly they're putting all that creativity of software developers into chains. And that is really something not very well appreciated by many of the people. because they want to have scalability at the, like in a data center. But the car, although being called data center on wheels, it isn't. It's still kind of a deeply embedded system, right? And yeah, so really getting through to the software development community, doing some design rules. Hey, you cannot do an fsync command with your 1 gigabyte database every 2 milliseconds. You will destroy the flash memory. How do you reach the community and really monitor what's going on? They face that challenge even more now because this complexity and the amount of people doing software has even increased.
And the times have changed, right? 10 years ago, suppliers were getting quote to build the hardware, build the software, do this, put it all together and deliver a package.
All integrated.
Yeah, including the design. At the time, I also had the design studios. We had over 720,000 different digital assets that had to be created for these platforms, which is just crazy. But over that 10-year period, okay, we're going to take in the design piece because that's critical to our DNA. Oh, we're going to take in more of the software piece because that's critical. All right, we're going to bid out the hardware to be built. You might get a traditional tier 1. It might be a Flex or somebody else that's going to do it. So, the whole world has changed, and it's the way it is. But that back to earlier, you still need to collaborate.
Yeah, I was just going to say it impacts us from the silicon perspective from a couple ways. First of all, the bottom line, if the silicon, you have to design it differently. And we have to make the devices that can do so much more now in a way that they can still develop in their old way, much like they have their own box. So the chips are now designed so you can actually isolate the chip, the memory, the resources, the memory bandwidth, so it looks just like a little MCU, ECU, but you can put many of them in the same thing. So they're totally isolated. There's also IP concerns because you're going to have maybe 10 or 15 tier 1s potentially running on the same chip now, and they need a way to isolate them from IP protections. They need to be running on the same chip at the same time. They may be all working in the cloud on the same chip even. So there's the bottom level, but there's also the top level. Everything is going virtual in the cloud. So we talk about virtual ECUs, virtual SoCs, virtual car, right? All of that's happening. Some OEMs are moving faster than others, but they're hiring people. We heard a great talk yesterday, and Ford talked about what they're doing in that area. Other people, all the OEMs, the major OEMs are building these validation and tooling teams, and they're bringing people from Apple and Intel and other places around that have expertise doing that. So you have to now provide these models, right? Not that they're going to be people working on their desktops in the past. Now they're all going to be working in the cloud through a virtual vehicle or a virtual box or a virtual SoC. And that's what's changed. So there is an owner at the top level at the OEM for validating that whole, either the box or the system. Mm-hmm. So that's what's really changing is the use of the virtual cloud. And so all the stuff we're doing now is cloud-based and be able to do it in the cloud, not just a board like we're talking about. It's not just now about having a board at your desktop anymore. It's doing it in the cloud. Mm-hmm.
I'm going to throw it to the group. One thought-provoking question. So I'm going to say, John, you got one? So we can end on a crazy note to get to Roger before we head to lunch.
I'm just going to call bluff on Brian's statement.
Which one?
The last one, simply because right now, DNCs plug it in, look for lights, and we're good. And I don't think people fully appreciate and understand the system design because they're not yet there. They would argue they're there, but they're truly not there. And you can simply see it by putting analyzers on the buses and seeing the amount of collisions that are happening. So I think to the point of designing software, this is a software design problem, and you validating the design of the software, not the hardware. This is simply by saying they're going to use the design of the hardware as a proxy for software, suggests to me that we are ways away. Ways away.
Maybe you clarify what you mean as a proxy, because this is all software-based. The hardware is just the platform.
Yeah, virtualized hardware, it's that we're not trying to validate the hardware. We're literally trying to validate the software.
Yes, that's the whole purpose of what's going on. It's about validating the software even early on. The software has been validated on new chips a year ahead of time. It's all about the software. It's about software from the low-level software all the way up to applications level. Okay. So that's not being missed. It's definitely that. It's about the software.
But are you still thinking the maturity of those virtual models is still where there's a gap?
More of the organizations and their ability to actually do that.
Yeah, that's the challenge, right? Is how do you shift and how do you train your engineers that are used to the old model of working with a board on their desk and developing a little microcontroller in their own little black box world? It's different now. Although, like I said, we're trying to help that by structuring the hardware so it looks the same, but physically you're part of a massive supercomputer at the same time. So
Mike, thank you for the opportunity, so.
Yeah, so once
appreciate it.
again, this is another foundation of what's gonna be happening this afternoon, where we're gonna be announcing this whole user experience area with this data, and then how do we cross over into future VSS elements, common elements, is a common testing. So once again, this whole area of trying to have open collaboration with OEMs, tiers, and practitioners is really our destination. So once again, thank you, panel, for coming